Hello students, I would like to go over equivalent equations with you for today. Beneath here, you'll see that there are three forms that you guys have learned throughout the school year. On the right, I provided you with three examples that we can use. Even though they may look different, these are all equivalent, meaning that they have the same solutions. At the very bottom, you guys will see some of the key features that you will be asked to find. Now, depending on what form you're given, some of these will be easier to find than others. The very first one that you guys have is factored form. Now, what key features are being highlighted by this form? Well, the first one is the concavity. Does the graph face up or does it face down? And so we can determine that by looking at the A value. If A is positive, the graph will concave up. If A is negative, it will concave down. So then we look at this part right here. We're looking at that number in the front, our constant. Since A is equal to 3, our graph will be concaving up on this example. A rough sketch of that looks something like this. The next part that we're going to look at is whether does the graph have a maximum or minimum. Well, if you look at your sketch, since it's going up, there is no roof to it, so it continues to go up, but it does have a low point to it, so therefore the graph will have a minimum. The next part that we can find is the intercept, more specifically the x-intercept. So if the graph crosses the x-axis, then it will create an x-intercept, and at that point, your y value at that ordered pair will be equal to 0. So then we take this idea of y being equal to 0, and we're going to substitute it back into this equation here. And so then when we do that, we get to this here. Now we're going to solve for x to find out what are the x-intercepts. So we can just divide by 3 and divide by 3. So then we have here. Now, x minus 4 times x plus 2 is equal to 0 when you multiply them. So then by the zero product property, it states that either one or both of these factors must be equal to 0. So then we can break them apart and write them in this format. We solve each one of them, and we get x is equal to 4, and x is equal to, sorry for that, x is equal to negative 2. So then now we have 4 and 0, and negative 2 and 0 for our x-intercepts. The next form that we have is standard form. Like the previous one, the concavity, same thing. We look at the a value, which is in the front. So our leading coefficient, again, is a is equal to 3. So therefore, concaves up. A rough sketch of that looks something like that. Our maximum or minimum, same thing. Because the graph is going up, it will not have a max, but it will have a min. The answer seems similar because they are all equivalent equations. The intercept, this time around, we can find the y-intercept a bit easier. So if the graph crosses the y-axis, then when it does so, your x will be equal to 0, and that will give us the y-intercept of where it happens. So then we take this idea of x being equal to 0, and we're going to substitute it into the equation at these two parts here. So when we do that, we get to this part. Now we're going to work out the problem. And so then when we do this part, we get 0 minus 24. And so then y is equal to negative 24. So then our y-intercept is 0, negative 24 for our y-intercept. And then the last one that we have is vertex form. So then, like before, same thing. We can find concave up or concave down by looking at the a value. And so then, again, a is equal to 3. We can find the max and the minimum by just knowing the idea that it will be concave up. So therefore, it will be having a minimum to the graph. And then, that was up. The axis of symmetry. So the axis of symmetry will intersect your vertex. Now, the vertex is found by taking the h and the k from your vertex form. So you take the h and the k and you're going to substitute it in. So then for our example, we get 1 and negative 27. So therefore, our axis of symmetry is x is equal to 1. All right, that's it.